Alrighty, first an apology. Had real big problems with my phone, with my account, and I lost a whole bunch of text messages. And I think I figured out who most of them are, but not everybody. If anybody sent me a message requesting a phone call from me, I saw it. I didn't catch the number, and I don't know whether it was from anybody in this class or another class. If it was somebody in this class, please send me another text. Or if you're actually sitting here in the lecture, wave your hand. Let me know. All right, so I've had some questions about the homework assignments. If the homework assignment says something like, well, I'll just type it up because I don't read. It's faster that way. If it says homework A, 2.1.5, and then it gives volume 1, whatever. What does that mean? That means find chapter 2.1.5, and in there will be a little there will be a little program in there, maybe 15 lines of code or whatever. Just type it in, run it, and understand it. No, you don't have to change it. If you feel like rewriting it, that's totally cool. But in this case, you're just typing it in and giving it a shot. Why are you doing that? Because not everybody here has had a version of fundamentals with previous Python programming experience. So you get some additional experience just in a general formatting and stuff like that, and in catching your own typos. So gives you a template of how you need to proceed in future assignments. So, alrighty. Yes, sir.
So when we, if we do, I guess when we do more stuff like that, if we change it, would it be an issue to add comments on the side?
Oh, comments are totally cool. Yeah, you can do as much as you want. And if you want, if you go ahead and modify the program in some cool way, when you upload it, put a comment there, brag about it. And that way I'll go, hey, that's cool, and I may even give extra credit for something like that. For example, what could you do to make these programs more interesting? Not necessarily more interesting, but that particular homework assignment was to do 4 little type-in programs from the book. You could make that a menu-based program where it asks, what do you want to do? Do you want to choose A, B, C, or D? And then based on that if statement, it would go ahead and execute the chunk of code from A, B, C, or D. Or you could put each chunk of code in a function, and then have it one script that had all 4 pieces, but all 4 pieces were on their own functions. And then you had some code that called those 4 functions. So you can try to make it more interesting, or you can just type it in and go to the next assignment. Either is fine. Another question I've had is if you see some code that looks like this, if name equals main, except it has some special symbols involved, has some underscores, and then it doesn't work, you get name is undefined, something like that, that's because it's really 2 underscores. And whenever I say it's 2 underscores, people would say, well, but I put 2 underscores. It's 4 underscores. It's 2 on each side, right? Just like if, there, replace those with underscores, and you'll be good to go. Now, why you need to do that, I don't think we covered that in class.
No. Okay.
So the point of, we were getting there, though, when we were doing some imports, and it ran the code that you imported. Let me give you an example of that. I don't necessarily want you to type this in, although we may come up against it again. May have you type in something similar to this, but not right now. So say we have some piece of code with some function, like define hello, and all it's going to do is print hello. Hi there. And then later on in your code, you actually call hello, like that. And then I'm going to save this, put it in my favorite scripting directory. I'm still quite organized that my full favorites folder is not there, so fine. Okay. So I'm just going to call this a.py. Now I'm going to make a new one. I'm going to put it in the same directory, and it's going to import A. Then it's going to print hi. So what is it going to do when it imports A? We will find out. And I'm going to save this one as b.py. So I have one program that is importing another script. And if you just came in, don't worry. You don't have to catch up with my typing at this point. So when I run it, whoops, unexpected character after line continuation. What did I do wrong here? What didn't know? Alrighty, sloppy. Let's go back and do it again. All right. So as soon as it did the import, it ran this line of code, which executed the function call. So, you know, if we run this one, it works great, right? This one doesn't have any imports. There's no unexpected behavior. But here, we may not have wanted it to run the code. In fact, very rarely when you do an import do you want it to get triggered and actually run some code that's in what you just imported. It'd be like if, you know, you open a map and then suddenly you were already there, you know, instead of looking at the map to figure out where you were going. That's a stupid, anyways. So we don't want it running this code. You know, we don't want print, please don't run me like that. But unfortunately, it's going to get run just because of our input statement. Even if we didn't have any code in here, as soon as we do an import, it's going to run that. Please don't run me. We don't want that to happen. So what we can do to get this code to still work the way we want it to, but for the imports to work as well, is we can do this. If underscore underscore name underscore underscore equals equals quote underscore underscore main underscore underscore, then do this stuff. What happens is if we ran this module, and I didn't make any syntax errors, and I put a close parentheses there like I was doing Java or C++. Try that again. Okay. What am I doing wrong here? I know what I'm doing. I just want you to tell me.
No colon.
Yeah, let's put the colon there. Okay. Alrighty. So it ran successfully. If I come over here and where's my other? I don't want to see that stuff get triggered just from my input, from my import statement. And now it's not. Print. This is all I want to see. So when I run this, and it did the import, it did not trigger any code here. Or, well, it did. I need to get rid of that notepad. It did, but there wasn't anything for it to do. What did it do when we added the import? It added a define, and then it brought this code in. But when we imported it, name was not equal to main. We could find out what it is. Print from the imported file, comma, underscore name, underscore, underscore equals, end quote, comma, underscore, underscore name, underscore, underscore. And then I'm going to go ahead and put this inside of b.py. So from the main code being run, so we're going to see two different versions of what name is. I'm not seeing the other one. It's probably because I didn't save the file. Yeah, if I come over here and I see star in front of the file name, that means I forgot to save it. All right, run that again. All right. So from the imported file, when it was importing the file, in that file, underscore underscore name is equal to the letter A. Now I cannot tell you why. Oh, because it's the file name, right? A.py. But in the file that I was running, underscore underscore name is equal to underscore underscore main. So what this is saying here is this a Python script being imported, or is this Python script being run? If it's being imported, we don't want it to run this code. If it's being run, we do want it. So the way that you get code that only executes when it is being run and not when it's being imported is to put that statement there. If you've taken other programming languages, you may be used to the idea of a main method. Well, we're kind of simulating that idea, not really, but what we're trying to do is to get us so that we can import these files into other Python scripts without them auto-running code. And so that's what that business is about. And if I was smart, I would make you add this every single time that you're typing code in class. It's a bunch of extra typing, but not that much. Maybe I'll get you in the habit of it. See if I get in the habit. I hope that's an adequate explanation of it. I'm going to paste this into our notes. Use this to prevent code in a Python file from triggering just because it was imported. On the other hand, if you want something to happen every time you import it, if you want it to trigger some code, even if the programmer who's using your library isn't expecting it, you don't need to put it in there. One way that I will structure code is to go ahead and define a main method, like you see in other languages. And then I'll call the main method from inside my if block. If you've never heard of a main method, or a main, I should be calling it function, excuse me, and module, for the guys who just got out of fundamentals. Never heard of that, that's okay. But what it is it's the entry point into the rest of the program. So we can put all of our code here, rather than just put it willy-nilly, unindented in here. And that's making it safer from being automatically run when the file is imported. Kind of makes sense, guys? 100%, 50%? I see some thumbs. If it doesn't, ask me more questions. All right, so we were talking about if statements and nested if statements and things like that. We know how to write if statements by now, I hope. If we were going to write this one, we would have if x equals y, and then colon. And indented under that would be print equal, else, colon, if x is less than y, colon, print less, else, print greater. Now it's conceivable that we could set this up with a bunch of change conditionals, which is if, elif, elif. But in this particular case, it's not. In this particular case, it's a nested if. If x is equal to y, print equal, else, colon, if x is less than y, print less than, else, colon, print greater than. This could be rewritten, considering the way that the logic is structured. If I eyeball the flowchart, I wish the screen didn't vibrate like that. When I eyeball the flowchart, if all the choices are mutually exclusive, if it's only going to do one or the other or the third, then that's a good case for using change conditionals, elifs. Why? Because it reduces the level of indentation. And, indentation is great, but it makes, if you have too many layers of indentation, too many nested things, then it makes the code more difficult to read. So I would have written it like this. If x is equal to y, print equal. I'm trying to save time. It is winding up taking more time. Elif x is less than y, print less than. Elif, or just else, print greater than. I don't know which one looks cleaner to you, easier to understand to you. This one looks cleaner to me. I would go with that one 99 times out of 100. The only time you can't set it up like that is if the things are not mutually exclusive. If there was some additional logic involved here, where some print statements, like if there was a print statement right here, then it's not mutually exclusive because that print statement would happen both for that branch and that branch because it would happen before that. So catching exceptions using try and except. I think we talked about that. What you do there, yeah, I remember us going on about divide by 0, is if you have some code that can crash, then you put it in a try block. And then you put the handling code in an accept block. And we may as well do this together. We're actually getting into some stuff that's, I know that we've already done this one. But this is Lecture E, so I'm going to make a new file. I got to ask them to fix that. That is really annoying. I don't know how y'all stand staring at that. Okay, so, you know, put your name, put the date. Hope everybody had a good Labor Day. Lecture E, we're still in Chapter 3, hopefully, of the online text. All right, so the first thing we're going to illustrate is try-catch. We're going to ask for a number. X equals input, parentheses, quote, enter an integer. I'm going to just make it int. Save my poor typing fingers. And now I'm going to convert it to an int using the int function. And then I'm going to, for whatever reason, I'm going to print out x to the power of 3, just so it does something. And I'm going to save it to my favorite directory. There's got to be a way to expand this to... When did it stop showing favorites? Do y'all see the favorites over here when you do a save as? Sorry to get stuck on that, but I create all my folders so that I can get to them within a second. And I'm not seeing them. Alrighty. Lecture E.py. So when I run it, first of all, I'm going to make sure it works. Enter an int. I'm going to type in 2. And 2 to the power of 3 is 8, so that's what I want to see. However, this is prone to failure because int is demanding that it be formatted correctly. No letters, no decimal points. For example, 1.0, it does not consider a valid integer. To my way of thinking, it looks like an int because there's no fractional part, right? 1.0, but in computerese, 1.0 is not the same thing as 1. And it blows up. Value error, invalid literal for int with base 10 anyways. We're just seeing that it could not convert. It's telling us what line, and it's telling us that it could not convert to base 10. Could not turn it into an int. Okay, I'm going to show you a cheap hack for fixing that. If you ever feel like doing this, you could do this, but then I'm going to undo it or comment it out. That makes an integer conversion that is more impervious to error. And what do I mean? It turns this string into a floating point number, and int is willing to convert a floating point number to an int. It's just not willing to convert a floating point string. So now I can type in some decimal points, like 1.1, and it rounds it down to an int. You might just tuck that away in your brain. If you feel like forcing something to be an int and you don't want to put try catch and stuff like that, or try except. However, try except is a good idea because what if my input is more wrong than just having a decimal point, like I type in letters? Could not convert string to float. I am going to comment this out and go back. I'll leave it. This lets the user type in decimals, but they will be ignored, rather than generate an error. But as you saw, if I typed in something that was invalid, like it had letters or extra punctuation or something, it blows up. And that's what I use try for. If I enclose this code in a try, and then I have an accept block underneath it, then that accept block will get executed if there is a failure of that type, but it will not get executed if there's no problem. So I'm going to put the word try, colon, here, and I'm going to indent everything underneath it, And then the last thing I'm going to do is have an except colon, and then indent some more stuff underneath that. So try that, that, and that, and then except colon, print bad input. Wasn't an int. Not that a general user wants to know what an int is, but we know. All right, so now when I run it, I can give it bad input, and at least it's not going to crash. It's not going to do anything good, right? The program didn't, successfully tell us the cube of the value, but it couldn't. The best thing to do would be to make it loop until the user gives us good information. And when we get to the chapter on looping, we'll do that. We'll write a little loop that'll catch all the bad stuff, and will not accept it until they give good stuff. I'm going to add one more statement here, or I'm going to put a print done here. Might wind up deleting that, but what I want to illustrate is what happens if you give good data. 10. And 10 cubed is 1,000 indeed. Notice what it did. It printed the cube value, and then it printed done. What did it not do? It did not print bad input, wasn't an int. This stuff only gets done if the try fails. It's kind of like an if statement. If failed, then do this. So the try stops at whatever point the error occurs. If an error occurs here, it doesn't do that. Put an extra print statement here to prove that point. Print after conversion. We won't see those words if we run it, but give bad data. Well, okay, I gave it good data. My mistake. All right, bad data. So it said bad input, wasn't an int. So it did that line. When I stay to the board and point, nobody at home can see what I'm doing. It did this line, right? It tried to do that line, but it failed, and so immediately it jumped to the except block. It didn't print after conversion because this is the point where it failed. And that's what try does. Kind of sets up a watchdog, so as soon as a critical error occurs, it jumps down to the except block. That is what's known as exception handling. And you'll see that in other languages. C++, C#, Java. All right, I know that's the second example of that, but it's important enough that I wanted to mention it again. What good would this be? What could we do that might make the program a little more useful? Is we could do something like bad input that wasn't an int, and then setting default value of 1, and then continuing our happy way. That way, at least the program could keep running. At this point, it really doesn't have any choice except to stop, right? We don't have a value of x. But we could restructure it. So we're going to do a little bit of restructuring. I'm going to take this after conversion line out. Don't want that anymore. I'm going to delete that. I'm going to cut that print x **3. And I'm going to add a print here, assuming default value of 1, or it could be anything, 10, whatever. And then we're going to print a message here that says, well, I didn't actually put the default value of 1. X is equal to 1. And then unindented, we're going to use the results of that. So if they typed in good data, x is equal to whatever they typed. But if they typed in bad data, x is equal to 1. And then we could print x, comma, quote, cubed equals, end quote, comma, x star star 3, like that. A little bit better of a message. And it's kind of lame for the inner and int to look like that with no spaces, so I'm going to go ahead and put a colon here. Do you have to do that? Colon space there, just to make our printing look a little bit easier. So to say inner and int colon. All right, I'm going to run it once and give it good data, and then I'm going to run it again and give it bad data. You should always test your program both to make it work and then to make it fail. I have too many scripts open. Get lost. Okay. One module. Inner and int. All righty, I'm going to type in some good data. 10 cubed equals 1,000. Okay, that worked. I'm going to run it again. Inner and int. Bad input. Wasn't an int. Assuming a default value of 1. 1 cubed equals 1. Why did I do that? Because we may have 100 other lines of code that we'd like to go ahead and keep running, even if they entered some garbage data, right? If your thermometer suddenly gives an erroneous reading, you know, it says it's 1,000 degrees or not, maybe you don't want the thermostat just to quit, right? You want to keep running, but maybe maintain the same state that it was in before. So that's one possible tactic of handling a case like this, is just to give yourself a default value. If you feel like it, you will impress me. Like if I ask you to write a program that asks for somebody's height and weight, and they give it bad data, so you assume a height of 5 feet 5 and a weight of 150 pounds or whatever you think are plausible defaults, that'd be pretty cool. Unless I ask you to do that, you won't get points off for not doing it, but it would be cool. Alrighty, this is slightly esoteric, but we got to talk about it a little bit anyways. Get lost. I want to structure our code here to be the best possible Python code. And what do I mean by that? I want all of this stuff to be in a main method. So here's what I'm going to do. I'm going to highlight all that stuff and then hit the tab key or come over here and click Format Indent. And then I'm going to define a function that makes this the main code. Define main, parentheses in, parentheses, colon. And then down at the bottom, I'm going to do that if underscore under name equals underscore underscore main business. So if underscore underscore name underscore underscore equals quote underscore under whoops under main under quote colon, then run main like that. Like that. So that's our code so far. Now why is this better? Because if we imported Lecture E into another piece of code, it wouldn't automatically run all this stuff until we actually called the main method deliberately. And you will see examples of this anytime you look up Python code online. Which is why I introduce it even if the book doesn't at this point. And I guess the online chapters do not either. Other textbooks I've taught from introduce that at an earlier point. Really, we're talking about functions before we have talked about functions in the lectures, though. So I apologize if this is not totally making sense. If you don't get what we're doing when we're defining functions, then feel free. Just go ahead and make all your code unindented, and don't fuss with this yet unless the homework tells you to. I know that one of my assignments already has done that. Okay, short-circuiting evaluation of logical expressions. We already know that if you have an if statement, something like this, if hungry and money, or if hungry is equal to true and money is greater than $5, then go out to eat. we know that both of these things have to be true before it'll print go out to eat. If we're not hungry, if hungry is not equal to true, it's not going to print go out to eat. If we don't have enough money, it's not going to print go out to eat. But what happens if one of these is true and the other is not? If this is false, if we're not hungry, does it even need to check how much money we have? And the answer is no, it doesn't have to check how much money we have because they both have to be true. So the language, and a great many languages are written the same way, so this is not Python specific. What it does is something called short-circuiting, which sounds bad. You know, I kept in the engines are short-circuiting. You know, no, it's nothing bad. Short-circuiting just means that if this part is false, it doesn't even execute this part. Usually that doesn't matter. Sometimes it matters though. If this was inside a loop that got repeated 1,000,000 times, and this was a function that took 10 seconds to call, and this was a function that took 1 second to call, you would not want to structure it that way because this would have to be called every single time, and it would take 10 seconds per call. You'd want to call the fast one first. You'd want to rule it out before you call the expensive one. So you would reverse it so that the one that takes less time runs first, and then the one that takes more time runs second. There are other kind of balancings you can do. What if we're hungry almost all the time, but we rarely have money? Then it might be better to put it so that the money greater than 5 is the first thing that is checked, because since we rarely have money, since we only have money 1% of the time, we wouldn't want to be checking hungry, because that would be checked all the time. That would be checked almost, you know, that's about enough of that. Short-circuiting of logical expressions. If you're using and the first expression is false, then the second expression is not evaluated. What if you're using or? Then the opposite is true. If the first one is true, then it doesn't check the second one. Like if we had this, if sick equals true or tired equals true, then print stay home. You already know that the way or works is that only one of them has to be true before it'll print stay home. If that one's true, it'll print that. If that one's true, it'll print that. If they're both true, it'll print that. The only time it won't print that is if they're both false. So if it turns out sick is equal to true, we don't even have to check that. And when I say we, the computer doesn't even have to check that, because regardless of this value, it would print stay home. So it optimizes the code. It short circuits the logic so that this is the only thing that is invariably checked. It's mandatory for this to be checked, but it's optional for this to be checked. And this is only checked if this is false. Just like this is only checked when this is true. Honestly, I don't remember if I asked any quiz questions about that. I probably don't. Just want it tucked away in your brain. The last, like I said, does this matter under ordinary circumstances? Not really, unless you're trying to optimize your code for speed. And if you're trying to optimize your code for speed, you probably shouldn't be using Python. The only time it would really, really, really kill your code is if you were really expecting this function to be called, if it was a function, it's just a variable, and this function to be called invariably, and the code would not work. The code would break if this one was not called every time this one was called, and vice versa. That's called tight coupling. You don't want your functions coupled like that so that they have to run in a particular order, or that two different functions have to run, you know, or your code will break. We would want some kind of loose coupling where it's okay if this one is called and this one is not. That kind of thing. I think I'll skip that. Debugging. The traceback that Python displays contains a lot of information, but it can be overwhelming. The most useful parts of what kind of error it was and where it occurred. So it'll tell you all sorts of stuff. Indentation error, unexpected indent. On which line? Line 1. Well, it sure would be nice if our editor showed line numbers. It does not, but you get the line number indicator way down in the corner anyways. You just have to put your cursor here and scroll up and down until you see, if I'm looking for line 17. Alrighty, well, nope, I went too far. Right, anyways. And then you get it. And then you compare that to the rest of the error message. So, when I'm wandering around helping out debug code, and you're getting an error and you want help finding your syntax error, go ahead and have your cursor positioned at the right line number. Not to save me time, although that's nice, but because as you are doing this stuff at home, you're going to need to get good at catching these errors yourself. I'm always happy to look at your screenshots, take a picture of it and send it to me, but you need to get good at that yourself as well. All right, a glossary. What is the body? That's the sequence of statements within a compound statement. Well, compound statement. I don't remember us hitting that term, so I'm going to go back here. A compound statement is anything that has a header like that and then an indented body. This if statement is a compound statement because it has a header and then it has a body. I don't care if you remember that term. I'm not going to ask about it on a quiz, but if you find it in the text, that's what it means. This is a compound statement, and this is the body of that compound statement. All of this is the body of the main, right there, of that definition, and this is the body of the try block, and this is the body of the except block. And yeah, I just said that all of this was the body of main, so that means that this is the body of the try block, but it's also part of main. Compound statement, a statement that consists of a body and a header. The header ends in a colon. And the body is indented. Logical operators, and, or, and not. We know what a nested conditional is now. Those are nested if statements. When one is indented inside the other. And short-circuiting. All right, I'm not going to assign you any homework from this web page, so we're going to go on and hit Chapter 4. And we're going through this stuff more quickly than the book. And like I said, I think that's okay because most of the homework that I give you is based on the book rather than what we do in here. I want you to understand what we're doing in here, but if you don't catch it the first time, you have a really good chance of catching it the second, right? Because you'll have seen it one time, and then when you see it in the book, it'll be, yeah, I know what we're doing. What in the world? Neat. How did I open that? I don't know. All right. Functions. A function is a named sequence of statements. It has a header, which is the name of the function, preceded by the def keyword. Then it's got some parentheses where you list some parameters. And then it's got, after the close parentheses, a colon. And then when you invoke the function, you give the name of the function. You then use the parentheses. And inside the parentheses, if the function takes any parameters, you provide an argument. So Python has a whole bunch of built-in functions. One book I taught from called them BIFs. And I thought that was obnoxious. BIF, built-in function. I'm not going to use that term again. For example, max hello world. What does the max function do? It checks this string here and returns us the character with the largest value. How does it decide what is largest? Because Z would be greater than Y, and Y would be greater than X, right? A would be the smallest of all. Now, normally I think of max as being useful in doing math, not for strings. And I'll show you what I mean. If you don't have your shell open, you might go to your shell, run Python shell. And if you do this, max of 10 or 20, it's going to say that that's 20. The max of 20, comma 10 is going to say still 20, right? Max of 1 or 1, well, 1. Max of 2 or 1, 2. It just checks the two arguments and returns the greater of them. If you've done Excel macro programming, you may have used the max statement, just like you may have seen the sum statement. Sum is another built-in statement. I wonder if we can do this. Nah, I'm not going to mess with sum until I see it shown in the chapter. Then there's min. What is the minimum of two values? 4 or 3? Well, the one that's lesser is 3. What if they are variables? X is equal to 10, Y is equal to 9, and then I type min x, y. Well, which one is smaller, X or Y? Y is smaller, so it's going to return the value of Y. So when I do this, it says 9. That's another built-in function. Whenever we're entering our code here, our built-in functions show up as purple, unless you change that. When you're creating variable names, if you start typing in something and you see that it's purple, don't use that as your own variable name, like this. Sum is equal to 0. In a lot of languages, that would absolutely not even compile. Python will let that work, but it's really poor programming even in Python where it doesn't, force it to break. What's happening here is we have a perfectly good function called sum, which will summon a series of numbers and, add them all up, and we are replacing it with a variable with the value of 0. We don't want to do that. We don't want to override a built-in function. So if you see something like that, show up as purple, give it a different name. And sum is such a good variable name that I resent not being able to use it. But instead I have to use total, and it's only 2 more characters. So len. Len returns the length of a string or of a list. Mention where we are. Chapter 4 online. Built-in functions. Min of x or y returns the smaller of the 2 values. Max x comma y returns the larger of the 2 values. And then len, whatever, I'm going to replace that with s. Returns the length of string s. So if s is my name, my first name, which is Jeff, then when I call it len of s, it would say 4. So example, len of Bob is 3. You can have a string of 0 length, which sounds odd, but you can. The length of that is 0. So type conversion functions, int and float. Then there's a third one, string. We don't use string too often. At least I don't teach using it too often. But it takes a number and converts it to a string, which might be useful. I'll give you an example of that. I'm going to go back to my code, and inside my main method, indented, because if I put it unindented, then it's going to be executed before this if statement. So maybe before the done, I'm going to do this. My string is going to equal the user decided that x equals end quote plus x. Now that's not going to work. That's going to be a syntax error. Why? Because the user can only the program can only concatenate string onto a string. Now I told you what concatenate means. It means appending. It's trying to append this to another string. But that's a number. It cannot be appended to a string. We would have to do that. And now it works. This is a string because it got converted by that function. And that's a string. So if I print out s, that'll work. If you're building a string, that's one way to do it. Sometimes you may need to convert some numbers into strings so that you can add them, so that you can concatenate them, append them to another string. Now I'm going to rewrite this one slightly so that it does the same exact thing, but with a string call. I think I'll comment it out though, because it does the exact same thing and we don't need to see it twice. So I'm going to put a hash in front of it. Oh well, I want it to do this. But what I'm going to do is I'm going to use concatenation. And so there we go. Notice I'm using a plus sign here to combine the two parts that I want to be printed. I could do that over here too. I'm going to do that. So here I'm going to add strx, close parentheses, and then a plus sign, and I'm going to put a space there. All right, these two print statements now provide identical output, assuming I have not made an error. Okay, yeah, they printed the same exact thing. Which one would you use? Well, I'd use that one, right? That's a lot easier to type. But if you were going to build a string, s is equal to, and then you had to add a whole bunch of things together in the string for some reason, like we did here, then this would be the way you would do it. You would use a string function to convert your numbers back to strings so that they could be concatenated to other strings. About time for me to make sure I haven't broken y'all's code. Good idea. All right, so the problems that I saw that I helped with, it's easy to make mistakes. For example, you could type that. Why is that wrong? Because you have to have matching numbers of parentheses. Here we have two open parentheses, so we'd have to have a closing parentheses. That wasn't the most common error, but we did see that. Or you could have a typo, right? You've typed str 7 times in a row, but the 8th time you accidentally put an I there. You know? And so in that case, the line number might give you a clue. If we ran it, when it blows up, it says stri is not defined. It gives you a line number. We can go to line 29. There I am, I'm on line 29. I could look at my error code again. stri is not defined. Or I could even just come back over here and hit Control F and look for stri. And there it is, and I'd spot my error that way. You do eventually get used to interpreting the error messages. All right, how much farther are we going to go? Random numbers. Oh, there was another point I wanted to make. Another common problem. I tried to have y'all indent a bunch of code, but may not have worked. What do I mean by that? Is several folk, when I came and helped, the code kind of looked like this. Why did it look like this? Because that's how we typed it originally, right? We didn't have everything indented. When I made this a function, when I put def main, I had to indent everything that was inside that function. When it finds something that's unindented, it thinks that that's the end of the function. So if this stuff was not indented, I kind of wish I had highlighted it all and chosen the menu to dedent it. But anyways, kind of looks like good code, but it says X is not defined. And you come up here and you go, oh yeah, I defined X, I see it right. No, it's because this is the first unindented line of code, so it thinks it's not part of this function. So if all this code was gone, is X defined? No, it's not, because all of this is supposed to be part of the function. And the book goes on, the chapter goes on to talk about random numbers, which are fun, but we need to really talk about functions. The way you define a function is with the def keyword. All I did is I went above main. And then you give the function a name, and then you use parentheses and then a colon. Print, I am Fred. I'm going to make another one. Def Barney. Print, I am Barney. Now here, I'm going to call them in the opposite order in which they're declared. Barney, parentheses, in parentheses. Fred, parentheses, in parentheses. So although it looks like it would print I am Fred followed by I am Barney, stuff that is in functions don't get executed until they're called. How are they called? When we provide their name followed by parentheses. So the first unindented line of code is this. And what does it do? It jumps up here and it prints I am Barney and it returns. Then it hits this next line of code, which is an invocation of the Fred function, which will run up here and print I am Fred and return. So when I run it, it should say I am Barney followed by I am Fred. And then it'll go on and it'll do all that enter and int, stuff like that. I am Barney and I am Fred. So the way the code ran this time is it saw a module definition. Okay, great. It saw another module definition. Great, it didn't do anything. It just defined some modules. Aha, now we actually have some stuff to do. That's our first line of code. And it executes I am Barney. This is our second line of code. It executes I am Fred. Then it keeps going down here. Oh, here's another function definition. And so it defines all that stuff, but it doesn't execute it. And then here's the last line of indented code. So our function ends at that point. Here's the next unindented line of code. Aha! So that's like statement 3, right? If the call to Barney was statement 1 and the call to Fred was statement 2, this is the third unindented statement. And it's a function, excuse me, it's an if statement that invokes name, which runs back up here and then does all this stuff. So I'm pretty sure that 90% of y'all have the idea of modules, as fundamentals called it if you took fundamentals or if you've done other programming. We're going to call them functions. Periodically I'll throw the word module back in just to trigger our brain, but we're going to call them functions from now on. We're not that textbook from 113. We're not using C-engage. So that is how you define a function. You can put stuff between the parentheses known as parameters. So like, we're going to write one called hello. That's going to take a name. And it's going to print I am, end quote, comma, name. Now is it going to print that? If I run it, am I going to see I am followed by anything? No. It doesn't print a darn thing because I never called the function. I only defined it. It's like writing a to-do list but not going to the store. Here I actually am going to invoke it. Hello. I'm going to make a mistake and not put an argument between the parentheses. So when I run it, it's going to be an error. And it blows up after printing I am Fred, and the error is missing one required positional argument. What it's trying to tell us is that I didn't put the thing inside the parentheses that was necessary. I needed an argument to fill in the parameter. Okay, I'll fill it in. So inside the parentheses, I'm going to put root. And now when it runs, it is calling the function, and it's calling it correctly with an argument to fill that parameter. And it's going to print I am Groot. Like that. So this is how you define a function that takes a parameter. And that parameter is filled by the argument that's called to it. If we wanted to send in 2 arguments, we could. Like we could pass in a first name and a last name. Well, I don't know Groot's last name, so I'm not going to make that change. We may be close enough to being done that I'm happy stopping. Anybody who wants syntax errors fixed, you got any? Wave your hand. All right. Let me make a Dropbox